or afternoon or evening, whichever you're watching this. Welcome again. Let's talk chemistry with Pastor Dan. We're looking at some terms involving chemistry. So let's start back at the beginning, which we could have done before. Chemistry. Chemistry is defined as, where's my little cursor? The study of matter in all its phases. So we're going to take these apart, each aspect of it, to make sure it's understood. So what's matter? I don't know. What's the matter with you? That's an old chemist joke. Matter is anything that has mass and takes up space. Now, when I was in school, the way that we define mass is quantity of matter, and that's fairly circular logic, and that's not a good thing. So instead, we're going to say that mass is a measure of inertia. What exactly is inertia? Inertia is a tendency to continue in a straight line. If a body wants to continue to move in a straight line after it's been trying to stop, that is the inertia. The more it wants to do that, the more mass it has. I've always said I thought inertia would be a cute name for a little girl. Can you imagine that? What's your name? Inertia. My wife would never go for that. I don't know why. All right, anyway, so inertia, the tendency of a body to move in a straight line. All right, now phases. Phases is a state that matter exists in, and there are 5 states of matter. Now you're going, wait a minute, I thought there were only 3. There are 3 that occur naturally on the earth. They are a solid, substance with definite volume and definite shape. So in other words, its size, what it looks like, and the amount of substance inside of it does not change. It's rigid. Liquid, substance with definite volume but no definite shape. So if I have 5 milliliters, I have 5 milliliters, but it fits whatever container it's in, so the shape is fluid, liquid. And then finally a gas, substance with no definite volume or shape, because we can change the volume by changing temperature, pressure, things along those lines. That affects the volume of the gas. Now, there are 2 other states that do exist. They're not permanent, long-term on the earth. One exists only short periods, bursts of, and that would be plasma. Plasma is a high energy state of matter. Where does it exert in short bursts on the earth? That would be lightning strikes. That would be plasma. The sun we believe is pure plasma, and as a result, it's a high energy state of matter. And then the last one is a Bose-Einstein condensate. It's a state of matter that exists extremely low temperatures. We have to get down to like 0.4 Kelvin. So it's extremely, extremely cold temperatures. Those are the different forms that form up. Now, we're going to talk about some concept called weight. Now, mass and weight aren't the same thing. The measure of the pull of gravity is weight. So weight can change, depends on how much gravity you experience. I always tell my that I'm going to begin a new company. This is my example. It's called the FWI. FWI stands for the Fenner Weight Loss Institute. Okay, weight loss is $1 billion a year industry. So here we go. I'm not waiting to make a lot of money for myself. This is what I'm going to do at the FWI, the Fenner Weight Loss Institute. For $1,000, I will guarantee that you will lose 100 pounds of weight, specifically saying weight, in 1 second. Now, how am I going to do that? After you sign the contract, give me a non-sue clause, a non-disclosure agreement, you hand me your $1,000, you walk into an anti-gravity room. This is Fennerland. I am God-imposed dictator life. I can do what I want. So in Fennerland, I have an anti-gravity. You go in that room, I turn on the anti-gravity room, zzz, suddenly there's no gravity. Your weight is 0 pounds. Did you lose 100 pounds of weight? Yes, you did. Am I owed $1,000? Yes, I am. Now here's the problem. Are you happy? No, you didn't want to lose weight. You want to lose mass, which is the measure of inertia. So as a result, they're not necessarily the same thing. Weight does change. If I go to the top of Mount Ararat, farthest point away, weight is slightly less. If I go to Death Valley, closest point to the center of the earth, weight is slightly heavier. Not huge, maybe a couple ounces, but there is a definite difference. All right, so phase changes. We'll talk about changes that exist in phases. If we go from a solid to a liquid, we call that melting or liquefaction. Melting if it's naturally liquid, liquefaction if it's naturally solid. If we Going from a liquid to a solid, we call that freezing. Freezing if it's naturally a liquid. Solidification if it's naturally solid. If we go from liquid to a gas, we call that process boiling if we force it. Evaporation if we let it happen naturally. Gas to liquid only has one term. We call that condensation. Solid to a gas. This is a direct process. Going from a solid to a gas is called sublimation, dry ice. Use that fog. They use that like Halloween and eerie kind of things. We call that sublimation. Go directly from a solid to a gas. The reverse process is called deposition, going from a gas to a solid. And those are all the phase changes. Those aren't too bad. Just get those copied down. All right, now we're going to finally look at matter. Matter can be divided into specific classifications. So I have two classifications for all matter, either homogeneous or heterogeneous. What's homogeneous? Substance that is uniform throughout, looks the same all without, there's no distinctive differences. Heterogeneous with distinctive differences. Now, we have two possibilities for homogeneous, only one for heterogeneous. So if it's heterogeneous, you only have one option, okay? So homogeneous. Homogeneous is either going to be a pure substance or a solution, okay? And heterogeneous is going to be a mixture. That's the only option you have. All right, so what is a pure substance? It's a unique substance. A solution, homogeneous mixture, okay? And what's a mixture? Mixture we have down there is two or more substances combined physically. We're talking about chemical and physical. In other words, what we had before, what we have after, same thing, nothing's changed. All right, so we end up heterogeneous right there. We don't go any farther. Element can be broken down into two things, either an element or a compound. An element is one of 118 unique substances, the stuff on the periodic chart that's back there. A compound, two or more elements chemically combined. So if I take hydrogen and oxygen, hydrogen's explosive, oxygen helps burn things, but when we put them together, we get water and we put out fires. So it's a new substance, different composition. Can we go farther than that? Yes, atoms can be taken down to, elements can take down atoms, we talked about before. Compounds form molecules. Atom's the simplest structure of an element. Molecule is the simplest structure of a compound. And of course, an atom can be a proton, neutron, and electron. So let's take and do a little practice here. I want you to go through each of these. Water, gravel, carbon dioxide, silver, salt water, sugar, Italian dressing, hydrogen, and milk. And I want you to identify them in what class. Class means homogeneous, heterogeneous. Type, we mean element, compound, mixture, or solution. And then state, solid, liquid, or gas, one of those three. All right, so copy those down. Let's do the first one together so that way we understand what we're looking at. So if we're looking at water, water's homogeneous. It looks the same all the way through. But element, compound, solution, or mixture, water is a compound because it's made of H2O. If you can make it into a formula, then it's a compound. And what state is it? Well, naturally, water is a liquid. Now, try to do the rest of these on your own, okay? So pause the video right here, work them through, see what we get, and as soon as we start it back up again, we will look at them. All right, so let's do the second set here. We have gravel. Gravel is heterogeneous. Because it's heterogeneous, there's only one option. It's going to be a mixture, and gravel is a solid. All right, let's do the rest of them here. Carbon dioxide is homogeneous, compound, and a gas. You exhale it, you can't see it. Silver is homogeneous, element, and solid. Salt water, homogeneous solution, because you can get the salt back in a liquid. Sugar, homogeneous compound, solid. Italian dressing, heterogeneous mixture, because again, we can see the difference. Heterogeneous mixture, liquid. Homogeneous element and gas is hydrogen. Milk, this one messes people up because they look. I only see one thing all the way through milk. Well, natural milk, as it comes out of the cow, is butter, fat, and basically water. So what you're drinking there is actually a classification mixture called an emulsion. We can have an emulsion, we can have a colloid, a little bit smaller, or we can have a suspension. Those are three classifications. Mixture I don't get into at this point. So it would be what we call an emulsion, basically fat suspended, So when you're drinking milk, you're drinking emulsified fat. And with that, we're done. Hopefully that wasn't too bad. Take care. God bless. Bye.